Hello friends, welcome to Learner's Planet. Friends, this is our sixth session for linear inequations. In the previous session, we discussed word problems based on linear inequations. In this session, we'll be taking the concept of graph, right? How do we solve graphical inequalities? Okay, so let's begin this session. Now friends, before we proceed further, let's have a quick recap of a 10th grade concept, that is how we make lines on a graph, right? Now this is origin, this is x-axis positive side, this is negative side, this is y-axis positive side, y-axis negative side, right? Now on this line x is 0, that is line of y, or we can say y-axis, and on x-axis y is 0. Right? Now suppose this is 1, this is 2, this is 3, this is -1, this is -2, and if I draw a vertical line like this. Okay, now this is the line that shows x is equal to 2, right? X is equal to 2. So this is the line shows x is equal to 2, right? This, if I draw a line over here this way, so that will show x is equal to 1. That means this side of this line shows the area, that is x is less than 2, right? So before this line x is less than 2. Okay, because the value of x is less than 2 in this side. Okay, here it is 1, 0, -1, -2, but in this entire number line, the value of x is less than 2. Okay, and in this side, if you see, the value of x is more than 2. So this is the line of x is equal to 2. In this side, x will be less than 2, and in this side, x will be greater than 2. Right? So if you have to showcase the area when x is greater than 2, then you will showcase this area. Okay, entire area. If you have to showcase the area less than 2, then you have to show this entire area. Okay. Similarly, this is origin x, x dash, y, y dash, and this is point 2. So this line represents y is equal to 2, right? As we move upwards, it's 3, then 4, then 5, and here it is 1, then -1, -2, right? So above this line, y is greater than 2, and below this line, y is less than 2. Right? And this line is y is equal to 2. So if you have to show the region where y is greater than 2, so that's an entire upper region corresponding to this line. And if you have to show y is less than 2, then the region that is below this line, y is equal to 2. So in this entire region up to infinity, y is less than 2. In this entire region up that is above this line, up to infinity is y is greater than 2, right? Here negative infinity, and this side positive infinity. But in this case, y will be greater than 2. In this case, y will be less than 2, right? Now here we are taking the values of x and y as constants, right? Now what if we have a relation of x and y? Suppose x plus y is greater than 5. Right? In that case, it is not a single point. It is a line that will be intersecting both the axes. Over here, this is the line that is parallel to x-axis. So it is just intersecting y-axis. Right? So value of x is constant everywhere. I'm sorry, value of y is constant everywhere in this case. Right? So x plus y is greater than 5, That means x plus y actually represents a line that will intersect both the x's. Now how do we draw these sort of graphs? Let's discuss in detail. Now here I have to draw x plus y greater than 5, right? This O, x, x dash, y, y dash. So to be able to draw x plus y greater than 5, first of all I'll draw x plus y is equal to 5. Now how do we draw this line? Just assume one of them to be 0 and find out the value of other. So when x is equal to 0, y is equal to 5, and when y is equal to 0, x is equal to 5, right? So y is equal to 0, that means the point is on x-axis. So this is the point where x is 5. Okay, that means the line passes through 5, 0 and 0, 5. 0, 5 will be a point on y-axis. Okay, so this line is passing through these 2 points. So I just draw the line. Okay, now this is the line of x plus y is equal to 5, right? This is the line of x plus y is equal to 5, right? Now what if the value of x increases? So value of x will increase this side. So if value of x increases, this expression will be more than 5. And if value of y increases, still this expression will be more than 5. So value of x and y increase this side, and value of x increases this side, right? So the region that is right side to this line will show x plus y is greater than 5, and a region that is left hand side of this line that shows x plus y is less than 5. This is the line of x plus y is equal to 5. The region right hand side or outside this shows x plus y is greater than 5, and left hand side, or we can say below region, shows x plus y is less than 5, and this is x plus y is equal to 5. Okay, so that's really important. Okay, we do more problems based on this concept. Now we solve an inequality that is 3x plus 2y is greater than 6, right? So first of all, what we do, 3x plus 2y is equal to 6, we draw this line, right? So when x is 0, y is equal to 3, and when y is equal to 0, x is equal to 2. That means this line will pass from 0, 3 and 2, 0, right? So this is the point 2, 0, and this is the point 0, 3. So I just draw the line that is passing through these 2 points. Now this is the line of 3x plus 2y is equal to 6, right? 3x plus 2y is equal to 6, right? So the region above this line, this side, will show 3x plus 2y greater than 6, and below this region starts from this particular, immediately after this line. Generally we draw broken line to showcase greater than sign, right? If it is greater than equal to, then we draw a solid line, because on this line 3x plus 2y is greater than 6, right? So we cannot include this line if 3x plus 2y is greater than 6. So this line will not be included. When line is not included, we draw broken line. Okay, and if line is included, suppose it is 3x plus 2y is greater than equal to 6, then this line is included. In that case we draw solid line. Okay, so above this line 3x plus 2y will be greater than 6, below this line 3x plus 2y will be less than 6. On this line 3x plus 2y is equal to 6. Now it depends upon the question if it is greater than equal to or only greater than or less than equal to or less than, right? If it is greater than equal to, then this line must be a broken line, because 3x plus 2y, if it is greater than 6, then this line must be broken line, because this line will not be included, right? Because on this line 3x plus 2y is equal to 6. So to show greater than, we will make a broken line. To show greater than equal to, will make solid line. Similarly, to show less than, will make broken line, and to show less than equal to, will make solid line, right? Less than region is this and more than region is this. Okay. Similarly, suppose I have system of inequations. I just have a system. I suppose it is maybe x plus y is greater than equal to 5 and x minus y is less than equal to 3, and we have to find out the common solution for these two linear inequations, right? Now what we'll do, we'll take the equation one by one. First of all, we draw the line for x plus y is equal to 5. So when x is 0, y is 5, and when y is 0, x is 5, right? That means this line will pass through 0, 5, 5, 0. So this is the line. That's 5, 0, and that's 0, 5, right? So I just draw the line. Okay, now this is the line of x plus y is equal to 5. Similarly, we can draw the line for x minus y is equal to 3. So x minus y is equal to 3. Okay, so when x is 0, y will be minus 3, and when y is equal to 0, x is equal to 3. Okay, so this line will pass from 3, 0 and 0 minus 3. So 0 minus 3 will be this side. Okay, when x is 0, this is, I just mark once again, O, y, y dash. So on this line, y coordinate is negative. So when x is 0, y is minus 3. So this point is 0, minus 3, right? And the next is when x is, y is 0, x is 3. So this will be somewhere here. So that is 3, 0, right? So we can draw a line from these 2 points. So I just draw. Okay, now we take the lines one by one. First of all, this is the line for x plus y is equal to 5, but we want x plus y greater than equal to 5. Now equal to sign is there, so we will be drawing a solid line, and x plus y greater than equal to 5, that means the region will be this. Okay, this entire region above this line, that will show x plus y greater than 5, and this line is x plus y equal to 5. So inclusive of this line, the right hand side region will show x plus y is greater than equal to 5, right? So this is the region. Now we mark the region x minus y is equal to x minus y is equal to 3 is this line. Now we want x minus y is less than equal to 3. Now I just changed the color of the pen to show x minus y less than equal to 3. Now this is the line x minus y is equal to 3, right? Now region this side will show x minus, the right hand side region will show x minus y greater than 3, and left hand side region, that is this region, will show x minus y less than 3, right? So just below this line. Okay, I'm above this line, right? The right hand side region will show x minus y greater than 3, and left hand side region will show x minus y less than 3, right? Now the common solution to both the inequations will be the area where we are able to see the green lines and the maroon lines. That is this region. Here you can say green lines and maroon lines, both of them. So this is the common region and this is the solution to both the inequations. Okay, this is the shaded region. I just it will include everything. Okay, so this is the region that is solution for both the inequations. Now next I have one more set of inequations. Suppose I have x is greater than equal to 2, y is greater than equal to 3, and the third is 5x plus 4y is less than equal to 40, right? So first of all, I just draw x is equal to 2, y is equal to 3, and 5x plus 4y is equal to 40. So here it is for x is equal to 2, it's 2 0, y is equal to 3 0 3, and over here when x is equal to 0, this line x is equal to 0, then y will be 10, and when y is equal to 0, x is 40 by 5 8. Okay, so this line will pass through these 2 points and this line will pass through 2 0, and this line will pass from 0 3. Okay, so this is, I just make the lines bigger. Now I have marked all the points. It's 0 10 and 8 0 this line, 0 3 this line, and 2 0 this line. Now what we do, we draw the lines. X is equal to 2, so this is the line x is equal to 2. Okay, then we have line y is equal to 3, so this is the line y is equal to 3. Then we have the line 0 10 and 8 0, so just take bit downside. Now this is the line that is passing through 0 10 and 8 0. Okay, now we have drawn all the lines. Now see, x we want greater than 2, so x will be greater than 2 outside this line. In this area x will be greater than 2, right? In this entire region x will be greater than 2. Okay, and next is y is greater than 3. So this is the line of y is equal to 3. So over here I just change the color. So in this area y will be greater than equal to 3. On this line y will be equal to 3. So in this side above this line y will be greater than 3. You can see the common region that we are getting. After that the third is 5x plus 4y less than equal to 40. So this is the line of 5x plus 4y is equal to 40. So less than will be this side, left hand side. Okay, this is the line of 5x plus 4y is equal to 40. So the area below this line will be 5x plus 4y less than 40. Right, now you can see the common region that we are having the green, maroon and purple lines. So that you can see this triangle, right? This triangle. I just change the color once again, this triangle. Okay, in this triangle you can see green lines, you can see this red lines and you can see purple lines. So this is the solution to all these three inequations. Okay, so I hope you are getting it. So friends, I hope you are clear with the concepts of linear inequations and how do we draw the graphical solution to linear inequation. How do we do the graphical solution of linear inequation we have discussed in this session. In the next session we'll be doing some more practice regarding this graphical solution of linear inequations. Okay, so I'll see you in the next session once again. Bye bye.